Good afternoon. And today we will demonstrate the Apollo system, mainly the part of its radio transmission and receiving of the radio wave reflections. The red object here in the center of the screen is basically our transceiver. It's the Apollo box that transmits radio waves and receive objects reflections. Each reflection is being fed into an artificial intelligence program that analyzes it, and by the material density, the speed of return of the reflection, etc., it calculates eventually the actual shape, creating what we call a computer vision system. You see here a number that this number is basically identifies the substance or the material density of the object. It can be any type, and we classify it like metal or plastic or a living tissue or any of that sorts. If I add actually a comment, we can see here that this object identified as material class B, which is again, the program has many classes. The radio wave we basically send to the object, and the reflection is returned to it, and from there processed by a computer program, an artificial intelligence neural network that does the analysis. Of course, in real life, it's going to be not just one ray, not just one wave, but many waves that are sent as the system receives the object's reflections to be analyzed and ultimately create the system, the scanned area map. The map can be of a 3D, it can be of halo, it can be of outlines, it can be silhouettes, or any other type of vision, I would say, or imaging. It all depends on the program that we're going to make, but the possibilities to create is basically any type of information. Eventually and ultimately, it all depends of how many radio transmissions we will set the Apollo box to send, and according to the reflections, it will provide us with a clear image of the scanned area. The scanned area, typically, it's a few hundreds of feet, but can be easily expanded using repeaters or extenders. Again, for this demonstration purpose, I'm sending here only a few, in this case, 2 radio waves. I can see the reflection identified, that means radio wave sent, the reflection was received. I calculate the density of the material and I identify the reflection. Here's another class A material for this one, and so forth. Now in real life, it will look something like that. Way more radio transmission, and naturally way more reflections going to be received by the system. I'll remove the comments per reflection just for clarity of the vision here. As you see again, each object gets its own density by the number. Each object can be identified also using which material it's made. Here we can see class A, class B, class C. We can get here also, there are comments in case the object is on the move. It tells us object is moving. So the system is capable of providing what we call a robust looking forward computer vision. It can be used in wide variety of applications. If it's in the health domain, measuring people vitals, detection falls, and of course, even furthermore, we can be used in airports to detect concealed objects, used in a warehouse to detect intruders, etc. For military purposes, we can use here the ultimate night vision system, completely radio-based. And that's only part of the strength and the advantages of the Apollo system. This is the what we demonstrate here. It's the software part that is taking the radio waves information and transmitting it, converting the transmissions into a computer imaging. And I will demonstrate now how it will look in real life. It's only, of course, partial. In real life, the system will transmit millions of waves per second with probably a few hundreds of millions reflections back to the box.